What we can do if this method doesn't work. I will show another one. It's a little more complicated because we will use a feedback loop. We assign UV to our trunk. Then we will find all connected branches to the trunk, assign UV on them, and then find all other connected branches and assign UV to them. And then we use some stop condition to our feedback loop that find that all branches has a UV. Let's starting to prepare for the feedback loop. Let's create a connectivity node. Assign it a primitive. Let's find which class has our trunk, and it looks like it's 0. Let's assign our UV texture. So type here class equal 0. So it's mean only on class 0 we assign this UV, use a cylindrical and 2 points. Now we see that our trunk has a UV. Next we need to create few more variables. Create a primitive wrangle. And use type if at class equal 0, we assign attribute integer attribute get equal 1. So we will use this attribute get inside the feedback loop to separate our branches with UV from branches without. And assign a detail attribute, set detail attribute 0 get 0 and set. So we have a 2 attribute get here on the detail, it's a 0, and get here it's 1 on trunk, and we have a UV attribute. Next I will use a boolean. So I need to find this border laying on the geometry, and to find this I will make a boolean, and I get seams exactly on these surfaces. So let's create a boolean. I do it because let's use a union and unique. I do it because my tree intersected. So if the tree have no intersection and all branches laying here, so it's unnecessary step. But for my tree, I need to do it because I will build a bounding box per each branch, then build a matrix, and I need a root point laying here to align all my branches along one axis and assign the same direction UV on each branch. And let's create, add a clean sop to remove all garbage after boolean. So let's check. So here we have 152 and 3, 152,381 points, and here it's less, so it's remove some garbage points. Okay, let's create a feedback loop for each with feedback and plug our tree here. let's copy input and use it, input data here. So put 1 for our test. So we have our tree, so we need to separate our tree with get attribute 1 and get attribute 0. Let's create a blast node. Blast, and type here add get equal get equal 1, and choose the primitives and delete not selected. So we have our trunk with UV with get attribute. Let's copy it and delete not selected. And now we have all other branches without UV. What we need to do, I need to isolate this cutted geometry. So let's create a prim wrangle because I need to use it, and type integer PR. We will use a fine attribute value because here we have all tree and here we have a trunk, but probably no need to do it. Yeah, we can use name attribute or better class. Yeah, let's use a class. So integer C prim. Oh no, we can. Yeah, okay. Let's use a find attribute. PR equal find attribute value. So this function looping through all primitives and finding the same attributes. 1 prim. We will look in class attribute and using integer at class on first geometry. Yeah, and now if it's found something, so x equal -1. If it's not find but this class in this geometry, we remove all primitives. Remove prim 0 at prim num and 1. Now okay, yeah, it should be like this. So it's take all geometry and look in this class in input geometry, remove it. Because next we will have a lot of different classes here, so we need to remove all other. And we need to isolate this one as well. Yeah, so we have a uncutted geometry and cut it, and here as well. Next, I need only these seams, so I will use a group primitive, and I will use unshared edges. So it will create polygons around holes. And I blast this group. Move So now we have only a root of each branch here, and I need to isolate only group of primitives that stay near my trunk. And to do it, I will create a primitive triangle. So we make a simple lookup. So we use our sims. And let's type integer pt equal near point. So we will look in a near point 1, let b, and distance 0.1. And if pt equal -1, we remove all points, remove all prims. Yeah. 0 at num and 1. Now we have only sims near the trunk. So let's isolate uncutted geometry, because I want to work with uncutted. Let's create a primitive triangle, plug it here, and use a find attribute to find all these primitive. Find attribute value 1 prim plus and p at plus, and if pr equal -1, remove all primitive. 0 at ptnum, primnum, and 1. And we have our uncutted branches.